I really like how my envelope generator feels to use. That's why I want to present to you how I'm doing it. But first of all, I want to play around a little bit with it so you can see something about it, and then you know what to expect from the upcoming code. So this envelope generator is being painted in relative time, which is a term that I invented to describe that an envelope always paints itself inside so that it just fits into the window of the component, which is different from envelope generators that have absolute time, where you often have some part of the component be meant to zoom around so that you can actually go to the place of the envelope that matters. I'm a big fan of relative time envelopes because then you can use really short parameter values and still have good control on the actual interface of the envelope and not just on the knobs. Of course, you will also see my modulation system again, because you can see the modulated value on this component, and it fades out when the macro knob is gone, just like on the knobs. As you can see, the shape of each state is individually changeable into this direction and the other one. Alright, let's get started with the code. So as you can see, I started by just calling my component, the envelope generator component, deriving from my component base class and from juice timer. I also defined that the MIDI buffer is called MIDI and that the envelope generator on the audio side is called envelope generator. Then I defined a bunch of states like attack, decay, sustain, release, attack shape, decay shape, release shape, and the number of parameters, so that I can have a point here that tells me how many of these I have. But then it goes on with attack shape mod, decay shape mod, and release shape mod, and the number of everything together. I will later use these mostly as index values. Just to give you a little overview, this component holds another component, which is the state component. Each of these three things is a state component, but there is also a state component for sustain, and it only appears when all of the other components are 0. Else it is gone, because we don't want to see sustain, as it's already implied by where this point ends. So let's talk about the member variables first. I have a bounds object, which is just so that the thing can have a little bit of a margin inside of itself. Then I have an array of PIDs, which corresponds to the different parameters that I will use. And also an array of parameter values, which uses the bigger num-params, because I need a lot of values. Also for StateComps, a legato button, an inverse button, and a velocity knob. So my envelope generator component is given my utils the different parameter IDs of attack, decay, sustain, release, attack shape, decay shape, and release shape, so that it can access the parameters. A tooltip, some default values and stuff. Here is the array of the StateComps. I think you have to use a C++ version higher than 11 for arrays to have an initializer list thing like this, which is something that confused me at first when I learned about it. So if you are still learning Juice and C++ and stuff, then keep that in mind. It is very useful to be able to initialize arrays, because otherwise you can barely use them, to be honest. At least not for components, because they're not copyable. So you would have to put them in a unique pointer if you wanted to use an array, and then what's the point of that? You know, you can just use a vector in the first place. Well, okay, so I'm starting by putting all of my values to 0 and adding and making visible all the parameters. And this is just my helper functions for giving my buttons and knobs nice visuals and stuff and functionality. And of course, I'm starting the timer. In Resized, I'm just giving everything its bounds, especially the bounds themselves, because they will be very important for where stuff is being drawn. And I'm calling the update function, because when you're resizing the window, the way the envelope is being drawn has to be updated. So you probably have to find new values for the width of the different things and stuff like that. The timer callback method is quite easy to understand as well. It just checks if you currently need to update the thing, and if yes, then update and repaint. Needs update works like this. The boolean e is just set to false, and during this very lengthy method, I'm just trying to find out if e is going to be true at some point, and then I return E. So what is E? We can, for example, look at the attack state. So I'm getting the PID from the array of PIDs. Then I'm getting the parameter from that, because this identifies the parameter in my in the framework that I slapped on top of the juice framework. Then I'm getting the parameter value, which is a normalized value. So I check if the parameter value is already the same as what I have in my array of parameter values, and if not, then I will put the value there and just say that I definitely need to update the entire thing. But while I'm already at it, you know, doing all this attack stuff, I also get the shape state and the parameter ID of the shape and the parameter of the shape and the value of the shape and also the modulation value of the shape. And then I check if any of these things have changed, and if yes, then yeah, I put them into the corresponding places in the array and set E to true. Now this is a very useful way of doing this, because this might have made E true or this, but it doesn't matter. If only one of them made it true, then it is true. And I can go on like that. I did the same for decay and for release. There is no shape on the sustain, so it's a little bit easier. So as you can see, it updates the entire thing every time that something happens. Like I'm turning a tag, and everything is being updated and repainted. And you might think that this is not ideal, but think about it. When I'm using the attack state, all the other states are moving as well. So that's just the thing with relative time ADSR envelope generator components. If you change one thing, it changes on everything. I could only make a little optimization to this entire thing for the shape stuff, because when I'm turning the shape parameters, I'm definitely only changing this thing visually. So the other things would not have to update, but I just did not implement that yet. And I still made this video on purpose because I sometimes feel like that it's easier to learn from resources that don't handle every edge case yet, because they just have the easier to read code. And if you're just getting started with writing an ADSR envelope generator, then you might not want to have the full solution, but just the solution that works for now. And then, you know, step by step finding the real solution. Wow, that looks bad. Anyway, now you are probably already waiting for a very long time for the main part of this video, which is what does the update method do, which is quite a lot. So first of all, I'm just getting the height from the bound so that I don't have to do that later with long text. Okay, so now I get the parameters of all of the time parameters of the ADSR envelope generator, and then I denormalize the parameter values so that I can actually know which time they correspond to. You cannot just use the normalized values directly here, because it might be that you have skewed your parameter, and I would highly encourage you to do that, because it just feels natural when the milliseconds on 25% are around 20, and then around 2 seconds for the center, but then go up to 32 milliseconds. A lot of synthesizers are doing it like this or very similarly, and it just feels right. So if you are using normalized values now, it would just paint the entire thing completely differently. It would not represent what the envelope is actually doing, and it would just feel wrong. I know, because I once tried to do it like this. So then I also get the sustain value, but I'm turning it around so that it actually is painted the right way around, because you know, Y values always go downwards instead of upwards. Now I'm adding all the node on times together, attack denorm and decay denorm, and also the node off times with release denorm, and I'm getting the denormalized time in general by adding those together. And if the time is below 1, which would mean that I neither dialed in attack nor decay nor release to a reasonable amount, then I only draw the StateComp, which means that I set all of the other components invisible and only set the sustain comp visible and give it the entire bounds. And then I am updating the StateComp with these suspicious values. I should only talk in depth about the update method a little bit later, but you can see these values are the start Y, end Y, skew norm and skew mod. So the last two ones are for the curviness, but since sustain doesn't have curviness, I just put 0 there. And the first two ones are start and end, which is also the same in a sustain StateComp, because you know, on the left side it is on the same height than on the right side. Let's say the time is actually bigger than 1, which means that there is some attack, decay and or release. So we set the sustain component invisible and care for the other ones now. I get the inverted number of the absolute denormalized time so that I can normalize these values again. But this attack normalize, decay normalize, and release normalize is something else than just getting the parameter values, because now it is actually in relation to the actual time. It's some sort of crazy thing to do, all this denormalization and then normalizing back in fancy ways, but it's just how it works. Multiplying the attack norm with the width and also decay and release, and that's again some sort of denormalization process, but this time I'm denormalizing it to the bounds of the component so that it can later give the individual state components their bounds. Now it always starts by asking if the attack size is actually bigger than 0, because only then it is worth it to make the component visible at all. Now we know that the attack size, decay size, or release size is bigger than 0. So we can just get the attack shape parameter and also denormalize it, just as we did in the beginning with the parameter values in general, and also for the modulation value. Now we can make the state component visible, give it the bounds, and we can update it with the values. Now the update method looks a little bit different in all of these state components. That's actually what makes the difference. As you can see, attack state always goes from 1 to 0, which means full height to no height. And yeah, it goes there in the way the envelope is being shaped. And it's the same for decay, going from 0 to sus, sustain. And for the release shape, we're going from sustain to 1. Now the funny thing about all this is when you are actually developing an ADSR envelope generator, you notice that sometimes the value doesn't even reach sustain before release state starts. You might be holding a node, you have very long attack time, and then you just decide that you don't hold the node anymore because it sounds good. So it would have to jump to the release time already at that point. And I covered that in one of my last videos already, how to deal with that on the DSP side. But I find it just funny that on the visual side of the envelope generator, you don't see any of that. Visually, it always looks like you're going through all these cycles, and only once you reach this point, you are allowed to go into the release state. That's something that confused me when I was coding my ADSR at the beginning, and I needed to wrap my head around that concept before I was able to really code that up. And then it was actually quite a breeze, in my opinion. Now you probably want to know what the StateComp even does at all. It also has a bunch of enums, but these ones are only because this inherits from knob. You know that I made my own knob class. I'm not using juiceSlider. This is my knob, but these StateComps are actually also knobs, just with a different design. You have to keep that in mind now. So this is a knob, and this is also a knob, even though it might not look like that. But you can see a bit that it's also a knob, because it also has the modulation, draggable, and the lock, with which you can make it be locked when the parameter values are being randomized. And I just noticed it does not work. Cool, that's nice to know. Does it at least work if I lock these as well? Oopsie. Oh yeah, that seems to work. Alright, so now I unlocked everything again, and apparently I still have to solve this issue where if I have multiple parameters that correspond to the same thing and I lock one of them, then it should definitely also lock the other one. Yeah, I have to write that down. It's funny that I always find my bugs when I'm actually making a video and not when I'm testing my stuff. It's like I'm using my stuff differently once I try to present it. Alright, so in the constructor of my state component, I am just using the make parameter function that I made for my knobs. And then I set the label to invisible, because usually there's a label that says attack, decay, sustain, and so on, but I don't need that on these knobs because it's kind of clear what they are. The first thing that I always do when I'm making a custom component that is interactable is that I make it responsive to mouse overs and drags, because when I'm just going over it, it should be painting a bit of a hover color, just like my buttons and stuff. It does that, as you can see. Is mouse over or dragging? Set color to my hover color and fill all. So if the path mode is not empty, which should always be the case, but you can never really know, then I'm just drawing that path with the modulation color. And it's the same for the normal path. When I'm overriding my own self-made classes, I always make sure that I call the base class methods as well, like here mouse enter, calling the knobs mouse enter and then only repainting, and also on mouse exit. The Resized method is also pretty straightforward. I'm just putting the mod dial and the lock button at some point. And now it's getting interesting. The update method that you have seen a little bit before. In the update method, I'm first of all asking if the state is the attack state, in which case the sku_norm and sku_mod variables that can be between -1 and 1 are being turned around. And the reason for that is that the method that is used for skewing, it just works the other way around for attack and decay, and that doesn't feel intuitive. When you're dragging up, it should go to this shape. When you're dragging down, it should go to this shape. Easy. So I'm turning it around so that it feels correct. Now I'm making sure that the values are being normalized and that they cannot reach 1 or 0, because that is forbidden in the method that I use for skewing the values. So I'm basically just looping from 0 to the width, going on always by my thickness value, get a new X value, get a new Y value, and then drawing the line from the last point to the current point. The getSkewed method comes from my DSP sites envelope generator. I have already shown you this in my other video, I think, but the little change that I made is that I made it static so that it can also be accessed without having an object of the envelope generator around. It is just the bias function. So that shows that the curve that is painted here is actually the same curve that is also used for the envelope generator itself, even though I don't use an envelope generator in my envelope generator component to draw this curve directly. Yeah, and then I'm just doing the same thing for the modulated value as well. There you have it, a MIDI triggered ADSR envelope generator component with modulation, with shapes, and with cool visuals that feel responsive in less than 400 lines, if you have already made an effort of some helper functions here and there.